In this system of equations, we already have the y isolated. So that's the piece. This expression is what we're going to substitute for y. So what I have to do is rewrite that second equation. But instead of y, I'm going to substitute 6x minus 11 because they have the same value. Now I have to finish writing the equation. So you'll see if I take that second equation, I've rewritten it, and the only thing I changed was y. I substituted 6x minus 11 for the y. And now we can solve it. So, of course, we're going to need to take care of the parentheses first. The negative 2x doesn't change. But when I multiply negative 3 times 6x, I get negative 18x. And then when I multiply negative 3 times negative 11, I get positive 33. Okay, pay attention to what happened there with those negatives. A negative times a positive is negative. That's why it's negative 18. But negative 3 times negative 11, the negatives cancel out, and that's why it's positive 33. Okay, from here, now we just follow the steps for solving equations, right? Combine like terms. Negative 2x minus 18x, that's negative 20x. We didn't change the 33, so that stays there. Now, our next step, we will need to get the numbers onto the same side, away from x. I'm going to use my additive inverse. Subtract 33 from both sides. That gives me negative 20x is equal to, why do I feel like that should be a negative 7? Oop, that's supposed to be negative 7. Sorry. This is from the CUDA software worksheet, in case you're wondering. Negative 7 minus 33 gets us negative 40. Now we have to take care of the coefficient. Because it's multiplying by negative 20, I want to do the inverse and divide by negative 20. These negative 20s cancel out. And negative 40 divided by negative 20 is 2. And we're halfway done. So remember, the solution is going to be a coordinate, right? Yep, let me make it smaller. So let me move that out of the way. Now let's solve for y. So I'm going to take the x, move it up here, and I can use either one of the equations to do this. I'm going to choose to do this first one. So it's y equals 6x minus 11. This is what we're substituting, right? Because that's what we figured out is the x. So I'm going to take y is equal to 6 times 2 minus 11. 6 times 2 is 12, and 12 minus 11 is 1. So there's our answer, right? We've got the x is 2 and the y is 1. And now we need to check, because you know what happens if you don't check. Woo, terrible things happen. So let me go back. I'm going to do it in green this time. I'm going to write out both the equations just so I have them. And this is negative 2x is equal, or I'm sorry, not equal to. What am I doing? I have negative 2x minus 3y is equal to negative 7. All right, so this is where we substitute. The 2 is going to go here, and the 1 is going to go there, because this is x, and this is y. So when I rewrite this, when I substitute, I get 1 equals 6 times 2 minus 11. 1 is equal to 12 minus 11, and that's true, 1 is equal to 1. So that means that the point 2, 1 is definitely on the line whose equation is y equals 6x minus 11. But now we need to check the other one, because it should work for both, right? Because that point of intersection is the point that lies on both lines. So again, instead of x, we're going to use 2. Instead of y, we're going to use 1. So negative 2 times 2 minus 3 times 1 should equal negative 7. Negative 2 times 2 is negative 4. Negative 3 times 1 is negative 3. And negative 4 minus 3 is negative 7. So it works for both. Therefore, our solution is definitely 2, 1. Okay, this one's from the same worksheet. This is actually number 8. Is it number 8? No, it's number 4. Sorry about that. So again, this one's a little bit simple for us because they've already isolated the y. So this expression is what I'm going to substitute here into the first equation. So I'm going to rewrite that first equation, negative 3x minus 3y, but instead of y, I'm going to put in the expression negative 5x minus 17. And then I finish writing the equation. So you'll notice the first equation is the same as what I just wrote. The only difference is I exchanged the y. Remember I said it's like having a $10 bill and two fives? They have the same value. You can exchange those. I'll give you 2 5s for a 10 any day of the week if I had any cash. Anyway, moving on. So with parentheses, we need to distribute. Now you need to be careful because look what's right there. That's a negative. You need to take it with you when you multiply. So when I resolve the parentheses, we don't touch that negative 3x. That stays the same. But now we're going to multiply negative 3 times negative 5, which is positive 15. And negative 3 times negative 17, oh, good grief, I don't know that offhand. Let's see, that's 121, 3, that's 51, I believe, plus 51. 3 times 7 is 21, 3. Yeah, it is, okay. Equals 3. Should have done that ahead of time. Oh, did you see my mistake? I made a little mistake. Did you catch it? Yep, I forgot the x. So that goes there. That was an easy fix. Okay, now we just solve for x. First, I'm going to combine like terms. That gives me 12x. Oops, okay. And then that's plus 51 equals 3. Subtract 51 from both sides, because remember I'm trying to isolate that variable. That gives me 12x is equal to negative 48. Okay, negative because the negative number is bigger. Get rid of the coefficient by dividing by 12, and we get x is equal to negative 4. Voila. Okay, but you know, we're only halfway done. We got our x. Let's go back and figure out the y. So let me minimize this a little bit. All right, it doesn't matter which equation we use, but I'm going to use the second one because the y is isolated. I feel like that's going to be easy for us. Instead of x, we're going to multiply by negative 4 because that's what x is. All right, minus 17. Oh, I forgot to do the check on the last one. Well, we'll do it on this one. Whew, now we simplify. Negative 5 times negative 4 is positive 20. And 20 minus 17 is 3. So there's our solution. Yep. Give me negative 4, 3. Now, oh, I did do the check. Let's do the check. I like doing it in green. I'm going to write both of my equations. I don't know why that marker looks so big. Equals 3 was one of them. The other one is y equals negative 5. Oops. Ugh. Negative 5x minus 17. Okay. This is x. This is y. Make my marker a little smaller. Thank you. So I have, where'd my colors go? There. Negative 3 times, instead of x, we have negative 4, minus 3 times y, which is 3, equals 3. That's 12. And negative 3 times 3 is negative 9. 12 minus 9 is 3. Hey, that one works. Let's try this one. Instead of y, we have 3. Instead of x, we have negative 4 minus 17. Negative 5 times negative 4 is positive 20. And 20 minus 17 is 3. And that's how we know we're right. 21. Ah, what's happened? I changed pages. So let's take a look at this one. This one looks pretty tough because nothing is isolated. We're going to have to do a little work in order to get one of our variables isolated. So let's see. I'm going to take the first one, and the first thing I'm going to do is subtract the 6y. So let me show you separately. I'm going to isolate x. So I'm going to subtract 6y from both sides. Okay, I think the dogs are going to be quiet now. All right, so that cancels out. That leaves us with negative 2x is equal to 6 minus 6y, right? I can't combine those because one has a variable and the other one does not. So you can't combine those and make 0y. That's illegal. So we just write them next to each other. Now, in order to isolate my x, I'm going to have to divide every term by -2. Don't forget, this subtraction is attached to the 6y. All right, -2 divided by -2, that cancels out. That leaves us with x, which is isolated, which is exactly what we wanted. Now, 6 divided by -2 is -3, and -6 divided by -2 is positive 3y. Okay, voila, we have isolated the x. It only took us 2 steps. That's not bad. So this is what we're going to substitute for x. So let's go to the other equation. We have -7x. So instead of the x, we're going to put the -3 plus 3y. We're going to slide that in where x is supposed to be. See? This equation is what I'm copying down here, but I have replaced the x with the expression -3 plus 3y because that is the same value as x. All right, but I got to keep going. Oops, I have plus 8y equals -5. Okay, yep, you got it. We have to distribute. That's what the parentheses tell us. -7 times -3 is positive 21. -7 times positive 3y is negative 21y. We still have the 8y. We still have -5. Okay, combine like terms. We don't touch the 21. We're going to combine these. So that's -21 plus 8, which gives us minus 13y. It's equal to -5. Trying to get the y by itself, so I'm going to subtract 21 from both sides. Right? This cancels out. Oops. Yep, this cancels out, which is why we use Sorry about that. That was weird. So that leaves me with -13y. And on the left, I can combine -5 and -21 because they're both constants. They're just numbers. And -5 minus 21 is -26. One more step. We need to get rid of the coefficient. That y is being multiplied by -13, so the inverse operation is to divide by -13. Any number divided by itself is 1, so that's essentially gone. So that leaves us with y equals positive 2. And we're halfway done. So we're going to take this 2. Oops, I meant to do that in blue. Prettier. And we're going to substitute it into one of the equations. Doesn't matter which one. I'm going to use the first one. Those numbers look a little easier to work with. So that's -2x plus 6y. Well, instead of y, I'm using 2, because that's what we came up with, is equal to 6. You see where that came from? It came from here. Right? All I substituted was 2 for the y, because now we're trying to figure out what x is. So let's keep going. 6 times 2 is 12. Trying to get x by itself, so I'm going to subtract 12 from both sides. This combines to make 0, which leaves me with -2x. Again, 6 minus 12, these are numbers. There's no variables here, so I'm allowed to subtract that. 6 minus 12 is -6. Finally, divide by the coefficient, which leaves us with x is positive 3. We have a solution. Our solution is 3, 2. Yep, that's a 2. There. But we're not done, are we? No, we're never done. Now we have to do our check. I think my dog is eating socks. Okay, I'll deal with her in a minute. So let's write our equations. We have -2x plus 6y is equal to 6 on the left. Our other equation was -7x plus 8y is equal to -5. Again, our coordinates are always in the order of x first and then y. So we're substituting for x and y each time, and let's see if it works. So we have -2 times 3 plus 6 times 2 equals 6. That's -6 plus 12 is equal to 6, and lo and behold, we are correct. Let's try this one. -7 times 3 plus 8 times 2 is -5. -21 plus 16 equals -5. It sure does. We were correct. Okay, this is probably the hardest problem on the whole page, and this is number 19. So you'll see nothing is isolated. So we're going to have to do a little work. And these are all we got even and odd numbers, and 17 doesn't look friendly at all because, ew. So I think I'm going to isolate the x. Let's do that one. So I'm going to take this equation, 2x minus 7y equals negative 17, and I'm going to add 7y to both sides. The reason I do that is because, oops, oh look, I found a highlighter. I want that to make 0 because I'm trying to get the x by itself. So that's my first step. Now notice here we have a number and we have a term with a variable. I can't combine these. The only thing I can do is write them next to each other. Okay, we're almost done. We're not done until the x is isolated. So my next step is to divide every term by 2. This cancels out, so we're good there. So it leaves me with x. Negative 17 halves. Well, let's see, 16, half of 16 is 8, so half of 17 is going to be negative 8.5. And then we have 7 halves. Half of 7 is 3.5 with the y. All right, we've isolated our x. These numbers look awful, don't they? But it's okay. We can still do it, right? Be brave. All right, so this is what we're going to substitute for x. So I'm going to take the first equation, negative 5x. So instead of x, we have negative 8.5 plus 3.5y. Let's see, that was a negative 5x. We still have minus 8y is equal to positive 17. I'm trying to keep an eye on that 17 because I know I'm going to mix up that negative somewhere. It's just my the way I am. So first we have to distribute because we want to get rid of the parentheses. So negative 5 times negative 8.5 is going to give us positive, 42.5. Yes, I used my calculator. It's way too late at night not to use a calculator. And then negative 5 times positive 3.5 is going to be negative, isn't it? Let me get rid of that. It's going to give me negative 17.5 y. Make my decimal a little more clear. Minus 8y is equal to 17. Notice this piece, it just comes straight down because we haven't dealt with it yet. That's not part of the parentheses, so I'm not multiplying that by negative 5. We only distribute the negative 5 to what's inside of the parentheses. Okay, moving on. Let's combine like terms. The 42.5, nobody touched that. Negative 17.5 minus 8 is going to be negative 25.5y. That equals 17. Trying to isolate the y, so I'm going to subtract 42.5 while my dog eats God knows what off the table. These make 0. So I'm good there. That leaves me negative 25.5y is equal to 17 minus 42.5, which is negative 25.5. Isn't it pretty how it worked out after all? We just had to deal with the decimals and the fractions for a second, but now we're good. All right, back to this. We need to get rid of our coefficient, so we're going to divide. Oops, didn't see anything there. My gosh, I got so distracted by that. Let me get rid of the y. We're dividing by negative 25.5. We don't want to get rid of the y. We want to leave the y there. Okay, these cancel out, which leaves us with the y. And negative 25.5 divided by negative 25.5 is 1. And we have a y. Yeah. Now all we have to do is solve for x. Take it all the way back to the beginning. I'm going to use that second equation. That was a little more friendly. 2x minus 7 times y, which we just figured out was 1, right? There it is. Oops. Minus 7y equals negative 17. So 2x minus 7 equals negative 17. Let's add 7 to both sides. That cancels out, right? Which is the whole reason we're adding 7 is to make that equal 0. We get 2x is equal to negative 10. Divide both sides by 2. X is negative 5. Voila! We have done it. We have a solution, negative 5, 1. But we're not done. Now my dog is going bananas all by herself. This is what we call the zoomies, which is hilarious when you have a 60-pound monstrosity. Moving on, let's do our equations. You know, I like green for this. Negative 5x minus 8y is 17, and over here we'll do 2x minus 7y is negative 17. So all I did was take these original ones and just rewrite them down here where I have room. Yep, she's eating socks. Awesome. Okay, let's see. We have x and we have y. We're substituting x and y and x and y. Okay, so we have negative 5 times x, which is negative 5, minus 8 times 1 is 17. That gives us 25. Minus 8 is 17, and no, that's true. 17 is 17. On this side, we have 2 times negative 5 minus 7 times 1 is negative 17. That's negative 10. That's minus 7. And negative 10 minus 7 is negative 17. We did it right. Okay. I think that was 4 examples, 4 or 5 examples. Let's do one more. One more, and I think you'll have it. All right, we've already solved the 2 hardest ones, so we're going to finish up with this one. Clearly, it's going to be easiest to isolate the y in this equation because the y doesn't have a coefficient. So when you're looking to decide which one you want to isolate, always look for the equation where you have a variable like this one where there's no coefficient, because that's just one less step. So I'm going to change this one by adding 5x to both sides. Y equals, again, on this side, these are different terms. This one has a variable, and this one doesn't, the other one doesn't. So you can't add them together. The only thing we can do is write them next to each other. All right, so the y is isolated. I'm going to take that second equation, I'm going to rewrite it, but instead of y, I'm going to substitute the expression negative 3 plus 5x. And then I have to finish, let's see, that equals 24. So see what I did is I took this equation, I rewrote it, and I substituted for y. Okay, so this y got replaced. Yes, okay. We need to distribute, that's a negative 8. So that's what we're multiplying everything by. So that gives me 3x, because we didn't touch the 3x. We can't just get rid of it, right? It's just not involved with our distributive property. So negative 8 times negative 3 is positive 24. Negative 8 times positive 5 is negative 40x. All that equals 24. All right, we need to combine like terms. That negative belongs with the negative 40. So 3x minus 40x is going to be negative 37x. We still have the plus 24. Subtract 24, so I'm trying to isolate my x. That gives me negative 37x is equal to 0. What? Yeah, that's allowed. So now I'm going to divide by negative 37. And that gives me x is 0. Now, a lot of people I've seen think that when you get something like this, like negative 37x equals 0, they mistakenly think that means undefined or no solution. No, it's okay. X can equal 0. That is totally legal. We have our x. Let's figure out what y is. We're going to take our expression. Let's see, it doesn't matter which one. I'm going to take the first one, negative 5x plus y equals negative 3. I forgot to substitute, didn't I? So negative 5 times 0, because that's what we said x is, plus y equals negative 3. Well, that's easy. Negative 5 times 0 is 0. So we're just left with y equals negative 3. And voila! We have our solution, 0, negative 3. So now, let's do our check. I do not know what my dog is into. I don't even want to look. Negative 5x plus y equals negative 3. Over here we have 3x minus 8y is equal to 24. We have our x, we have our y. This is what we're substituting. I like when 0 is one of my coordinates because it makes this part easy, doesn't it? So negative 5 times 0 plus y equals negative 3. Oops, hello. Oh my gosh, the dog has me very distracted. I apologize. I forgot to substitute the y. It's negative 3 plus negative 3. That's 0. And we're left with negative 3 equals negative 3, which is true. On this side, 3 times 0 minus 8 times negative 3 equals 24. Okay. This is 0, of course. And negative 8 times negative 3 is positive 24. And that's correct, too. So there you have it. Several examples. I hope this helps make it a little more clear. And I hope you enjoyed the background music by my crazy dogs. Bye.